Thank you. I won't really introduce myself. The only thing you need to know about me is that I'm a full-stack developer. That's the proof. I can handle both cats and dogs. I couldn't bring them with me today. Unfortunately, the organizer didn't allow that. But at least I brought my rubber duck. Because today, we're discussing a rather tricky question. I forgot the clicker. And the question is testing easy in 2025? And before we jump in, a quick check. Can you please raise your hand if you worked with Playwright before? I would say 40% of the audience, maybe 40, OK. So for the rest of us, a brief introduction to Playwright. It's a popular end-to-end testing tool. It's very easy to install. With just one command, you get the default configuration, browsers, an example test, even GitHub Actions workflow. Great. It also comes with code gen. It allows you to record tests without actually writing any code. You basically click around, and you get back a simple but functioning test code for very basic use cases. Now, when you face more advanced test scenarios, Playwright has all the features: visual comparisons, snapshots, API testing, Chrome extensions testing, components testing. If for some weird reason TypeScript is not your language of preference, there are other options too. When tests inevitably fail, Playwright offers best-in-class developer experience with built-in debugger, VS Code extension, reports, screenshots, videos, AI button, and my favorite, the trace viewer. The trace viewer is a one-stop shop for any test failure. It provides details about every test step you have with console logs, screenshots, network requests, and basically everything that you usually check in the browser DevTools. Playwright is a practical tool. It has auto-weighting and web-first assertions to reduce flakiness. Authentication and multi-user support comes out of the box, same with parallelism and sharding when your tests grow large. Finally, Playwright has great community that provides plugins, best practices, and integrations with other tools. All in all, Playwright checks all the boxes to make testing easy. At least, this is what I thought. When a year ago I joined a team at Aetion, a healthcare analytics company that provides a range of products for data scientists in the healthcare sector. It's a highly regulated and specialized business domain that probably has acronyms for pretty much everything in the world. Let me give you an example. In the International Classification of the Diseases, it's a real thing, there is a code, W6162XD, naming is hard, that means, it literally means struck by duck subsequent encounter. This is precise science. And in this very particular business domain, our team was asked to cover all the major features with automated tests. The scope included 64 epics of tests. I still remember this number. The UI, for a non-professional like me, looked like gazillion checkboxes, acronyms, tables with random numbers all around. All that powered by 5-year-old React application and 10-year-old Java backend. The backend had its own journey from from monolith to microservices, then back. I always mix those two. And that left us with a bunch of outdated legacy API endpoints. But that's for another time. For now, let's focus on React. As the product was evolving, some of the components have grown over 1,000 lines of code with those huge use effects with missing dependencies and dependencies array and all that stuff. React version 17, most of the code untyped. ESLint and Prettier got lost somewhere between cloud migrations. And I want to pause here just to mention that this is not an uncommon situation for growing businesses that focus on building new features. Having that said, our first reaction to this regulation project can be summarized by a quote from my teammate. This code is impossible to test. Or, speaking scientific language, R45.4, irritability and anger. Challenge was not accepted at all. With all those excuses in my head. No, it's not my job. Even a junior can do that. Even AI can do that. And after 5 hours of prompting ChatGPT, stupid AI, it will never take my job? OK, I'll write the test. Just tell me what kind of test we are writing. Where do we even start? We needed a testing strategy. And now it's time for a short theoretical block. Probably the most popular testing strategy out there is the testing pyramid. It promotes breaking software into small, testable units. Not our case. The other option is to turn the pyramid upside down and to get the reversed testing pyramid. Now, if we put a bit of ice cream on top, because why not, we get the default testing strategy for many companies, the testing ice cream cone. Most of the testing is manual, and only some of that gets automated. Not that tasty. Yet another option we have is the testing diamond. It focuses on integration tests. An evolution of the testing diamond that is more popular in front-end community is the testing trophy by Can't See Dots. It's cool. It clarifies what different types of tests mean in the context of the modern JavaScript ecosystem, and also makes static checks such as TypeScript and ESLint more explicit. Now, that's a lot of great strategies. But unfortunately, none of them quite fit our immediate use case. So please welcome brand new testing strategy, the testing mushroom. The cap of the mushroom is all about end-to-end tests. They clear the regulation requirements and also build a safety net for us to start refactoring and bring in integration and unit tests. The testing mushroom is a living organism, so it's expected to grow and change its shape as we learn more. Now we've got our great strategy. Finally, it's time to execute. The whole team sat down to write as many tests as possible, as fast as possible. And a month later, someone ate too many mushrooms. Didn't work. Didn't work at all. The more tests we were writing, the more of them were failing, with all the random reasons, and it was taking ages to figure out what was going on. It was time for an emergency action, namely, reading documentation. At least the best practices part. Apparently, most of our tests were flaky because we misused Playwright APIs. The line at the top is the wrong way to check welcome text on screen. And the line below is the right way to do it. Both work, the first version sometimes randomly fails. And honestly, the difference is subtle, especially when you review hundreds of lines of test code. Luckily, the solution is simple. We installed ESLint plugin Playwright, and it helped us fix all the issues and also learn what was the right way to use Playwright. With that, we continued writing our tests, and 2 months into the project, we realized we're behind schedule. So we had to ask our colleagues from other teams for help. And this is when we faced our next challenge: test dependencies. As you remember, we're dealing with a quite complex business domain. A typical user journey can take several minutes before you get some meaningful results. For a developer, it's tempting to reuse results from previous tests to build new tests on top of them. Unfortunately, it completely breaks test retries and makes local debugging impossible. You never know in which order and which test to run on your local to reproduce the issue. Once again, we checked the best practices, and one of them says, make tests as isolated as possible. Easy to say. We had to enforce it with full parallel mode, and we also increased the number of workers to 3 so that they actually run in parallel. That revealed a few issues that we fixed, and now, finally, we've agreed. The test started catching real bugs. Just like that one in the top right corner. Let's actually check what's wrong with that. That's my test. I wrote it. And for me, it's very easy to see what's wrong with that. It's a backend issue with one of the APIs not returning the right response. So I'm pushing this issue back to the backend team. They open that, can't understand anything, and push it back to us. And we push it back to them. Z63.1, problems in relationship with in-laws. Apparently, our tests were not readable at all, and we had to fix it. When it comes to organizing our code, we already knew how to do that. You break your code into small logical pieces. Like here, for example, we have page object model, login page contains all the actions that you can perform on that page, like login, logout, password reset, etc. Now, we already had this structure, and apparently we were just one step away from having the same readability in our reports. And when I say one step away, sorry, I keep messing with this. Can you hear me fine? Yeah. So, back to the steps. So, there was one step missing, and it was literally named step decorator. With that, Playwright groups lower-level instructions into higher-level logical steps that are much more readable. This is not available by default in Playwright, but you can enable it. There is documentation how to do that. With that, our test reports became much more readable, and even our lovely backend team could figure out what was going on. If I zoom out a little bit, this is how the test report looks like for a failed test. It provides all the steps along with attachments, screenshots, traces, test retries, test history, tagging, and all that stuff comes from Allure reports. Allure report is an open source, cross-platform, cross-language test reporting tool that allows you to add these nice visualizations on top of your test that allow even non-technical people to read your test. With that, finally, we were on the finish line. Yeah, I need some help. Sorry about that. OK, so we're on the finish line, and we're about to wrap up the project and book holidays when our platform engineering reached out with a much bigger problem. Yes, our tests are green. Yes, they're stable, but they're super slow. They block deployment pipeline for an hour or 2. That's not acceptable. And honestly, we never focused on speed. We had other priorities. As a reminder, we run tests in full parallel mode in 3 workers. And this is another visualization that Allure Reports gives us that shows how tests are distributed across different workers. With just one configuration change, we could go from 51 minutes to 17 minutes. Yes, we just increased the number of workers. The white space at the beginning is the room for improvement, but it was already a great first step. Now, that of course doesn't make your individual tests faster. It just runs more of them in parallel. If we compare end-to-end tests with integration tests usually skip or mock expensive operations, which end-to-end tests usually don't do. But in Playwright, we have network APIs for intercepting HTTP requests. I personally am not a huge fan of this approach. In one other project, we mocked all the network requests, and our test was super green, super fast, but they've never caught a single bug. Instead, we were constantly regenerating and updating the mocks. What if we could gain similar performance benefits, but without actually maintaining mocks? Mocking without mocks, as I call it. This is exactly what Playwright Network Cache offers. Let me show you how that works. Imagine we have 5 tests. They all start by performing some expensive operation, opening a test project. It takes, on average, 3 seconds. With Playwright Network Cache, very first test will perform the expensive operations, store result on disk, doesn't matter, GET, request, or POST, and all the other tests will use them as mocks. In our case, we had 200 tests, so we've got back 10 minutes with this optimization. Super cool. But if you think it's cheating, you're not wrong, because it's no longer a pure end-to-end test. And that's why, in the testing mushroom, our integration tests sit inside the mushroom cap. And I could talk more and more about the testing mushroom. It's just a lot of fun. But honestly, I made it up completely for the purposes of this talk to illustrate the approach we took for this particular project. And your approach will be different. I hope the testing mushroom inspires you to explore the different shapes and strategies out there and find what works for you and makes testing, if not easier, then at least more fun. With that, it's time to wrap up. To follow tradition, I wanted to pause here and to thank the organizers, MCs, speakers, and all of you for making this event so special. A huge round of applause. Now let me recap. We wrote all the tests. Mission complete. They're stable and readable. They catch real bugs. They run in full parallel mode. Great job to the team. But there is something else that I didn't mention, an unexpected side effect. Today, 1 year later, we have React and other major libraries upgraded. We deprecated the outdated integration tests that used those old mocks that nobody knew how to maintain. The team switched to monorepo to improve developer experience. We migrated to feature-sliced design to align better with our business domain and also to start breaking down our code into smaller testable units. All that accelerated TypeScript migration. And it helped us develop new features faster. Today, a year later, it's a completely different code base. But I know it all started with testing. So back to the question. Is testing easy? It depends on the right strategy, discipline, and skill. But the good news, everything else becomes easier when you've got your testing right. And my favorite, RP 202.5, obsessed with testing and React very.
Thank you